In this question, it asks you to write an equilibrium expression for the equilibrium constant Kc. Kc is given as the concentration of Z, which is on the right hand side, divided by the concentration of X and the concentration of Y, but Y has got a 2 in front of it, so Kc is the concentration of Z divided by X on the bottom, because that's a reactant, and Y is a reactant, so that ends up on the bottom as well. But Y is to the power 2 because there's 2 lots of Y as reactants, 2 moles of Y as reactants. When you rearrange that, Y squared across the other side of the equation ends up on the top, and Kc ends up on the bottom, so you can rearrange it to this. And then it says that, or you could put the numbers in, I suppose. Kc is 2.9, it tells you Z is 0.35, it tells you X is 0.34 times Y squared, so Y squared equals that, and Y squared will come out as 0.55. The student added more Y. Well, if you add more Y to this, if you add more Y, by Le Chatelier's principle, Y is going to get used up. So Le Chatelier's principle says whatever you do to this equation, it will oppose or go against that change. So if you add more Y, it will be moved across into Z, it will be used up, and it will make more Z. So this will get used up, make more Z. It says Z is orange, so we're going to get a darkened colour. We're going to get more orange because the equilibrium moves to the right hand side. We get more Z made. And the reason that happens is to try and use up some of the Y that's just been added. What would happen if you warmed it? Well, let's have a look at the equation again. Well, going left to right, going across the right hand side, it's an exothermic reaction. If you warm it, it will try and cool it. The way it could cool it is move to the left hand side. If the equilibrium shifts to the left hand side, then some of the Z is moved across to the left hand side, used up, so the colour would fade. Sodium bromide, we've not done that one yet. A colourless solution, so we're going to miss that one out, you've not done group 7 yet. A colourless solution contains a mixture of sodium chloride and sodium bromide. Using silver nitrate and any other reagents, explain what you do. Well, you don't need to list all of these, but you'd have to add some silver nitrate, and it's going to form some silver chloride and some silver bromide. If you know the formula of silver nitrate, AgNO3, and you know sodium chloride, NaCl, then you can work out the equations, and NaNO3 is sodium nitrate. That's got to be formed. And then you want to make as much sodium bromide as you can, so you've got to get rid of the sodium silver chloride. You want to try and make as much silver bromide as you can, get rid of the silver chloride. Silver chloride dissolves in ammonia, so you'd add some ammonia solution and it would dissolve the silver chloride. Silver chloride dissolves. You're not going to know that equation, so you can not bother with that mark. We'll get enough from the rest of it to get 4 marks. There's enough off some of the other things here to get 6 marks. Separation and purification of AgBr, well, it's a precipitate. It's a cream precipitate, so you'd filter it, wash it and dry it to get it out. An ionic equation between chlorine and sodium hydroxide, you've not done that yet. We've not done group 7 yet. So this is quite a difficult question. So first of all, you've got to realise that it's thought to be calcium hydroxide. It's probably got some impurities in there because it's thought to be calcium hydroxide, but it's probably not all calcium hydroxide. We've got to react it with acid, and we've got to react it all the way, so we're going to have to use an excess of acid. That will get you a mark. You've got to work out the moles of the acid, so probably the first thing to do is work out concentration is moles divided by volume. So if you rearrange that, If volume comes up and across to the other side, then moles is concentration times volume. It tells you the concentration is 0.2. It tells you the volume is 50 centimeters cubed. You've got to convert that into decimeters cubed by dividing by 1,000. So the number of moles of acid is 0.01. You've got to realise that for 2 moles of acid, you only react with 1 mole of calcium hydroxide. So 2 of these react with 1 of these. Half as much of this reacts as you've got of this. So you've got to divide it by 2 to work out the number of moles of calcium hydroxide. So that equals 0.005 when you divide this number by 2. So then you've got to realise that moles is mass divided by mR. You can work out the relative formula mass of calcium hydroxide. The calcium's a 40. Hydroxide is O and an H, and you've got 2 lots of those. You've got 2 O's and 2 H's. So you've got 2 16s and 2 1s, and it comes out as 74. So the number of moles that you need of calcium hydroxide, we've just worked out here, is 0.005 times 74, 0.371 grams. That's how much you need of this. Then you're going to react the 2 together. So you're going to get some acid in a pipette or a measuring cylinder and add it to the solid, maybe in something like a beaker or a conical flask. And then you need to work out how much acid has been left over, because the acid should react with this and all of the acid should get used up. We've worked out the number of moles of each that need to react, but it's thought to be calcium hydroxide, so some of it will be impurities. So we can react with sodium hydroxide, adding some sodium hydroxide in a burette using a titration method, and when the indicator changes colour, I'm going to suggest something like phenolphthalein. Phenolphthalein, when the sodium hydroxide is added to it, will go purple. You can work out how much acid has been left over and not reacted. For the sodium hydroxide, its concentration suggests about 0.1 mole per decimeter cubed. That's fairly standard for a titration, 0.1 moles per decimeter cubed. So the number of moles of sodium hydroxide will equal 0.1 times the volume of sodium hydroxide that's been used. Now sodium hydroxide and HCl react 1 to 1, 1 mole of that reacts with 1 mole of that. So you've just worked out the number of moles of HCl that have been left over. Remember, number of moles of HCl is 2 to 1, so you can work out the number of moles of calcium hydroxide that has not reacted, that has probably not been there and been as impurities, by dividing by 2, and then you can subtract that from the 0.05 and work out how much calcium hydroxide you've actually got in there. So you've worked out the number of impurities, number of moles of impurities, subtracted it from the mass that you have, and then you can use mR as mass divided by moles to work it out. You can't actually work out the value, you've just got to explain what you're doing. Quite a difficult question that, so unlikely you're going to get all 8 marks, you might get a few along the way. Calcium chloride was dissolved in water, react with sulfuric acid. The percentage of calcium sulfate from calcium chloride and the sulfuric acid was 83.4. So you can work out the number of moles of calcium chloride. Remember, moles is mass divided by relative formula mass, so you need to work out the mR, the relative formula mass of calcium chloride. You've been given its formula there, so that's a 40 and 2 lots of 35.5, so that's 111.1. So moles is mass divided by relative formula mass and comes out as 0.03204. Moles of calcium sulfate, again you can use the same thing here. So calcium chloride is the calcium sulfate that's made. Calcium chloride reacts with sulfuric acid and makes calcium sulfate. So we worked out the number of moles of calcium chloride that we've got, it's going to make the same number of moles of calcium sulfate, but we've only got 83.4%. So I've taken 83.4 divided by 100 and multiplied it by the number of moles of calcium sulfate that I've made, which is the same as the number of moles of calcium chloride. So that's the number of moles of calcium sulfate that I've got made based on 83.4% yield, and then moles is mass divided by relative formula mass. So moles is mass divided by relative formula mass. So the mass is the number of moles there that I've just worked out multiplied by the relative formula mass, and it comes out as the number of grams that I've got made.